Right. So this is the beginning of Border Gateway Protocol, Border Gateway Protocol, BGP. Very popular. Everyone would have at least heard this word BGP once if they are in networking field. Even though this BGP is not seen everywhere, but everyone knows about this protocol. It is because this is the protocol for internet. Without this protocol, internet is very difficult. The internet's path selection is more policy based, is all because of this BGP. If not, to have policy based path selection using other protocol would have been very difficult. BGP has got attributes which contributes in policy-based path selection, unlike other protocol. This has got attribute. The other protocols, they got metric. Attributes and metric, they are not same. Metrics of BGP is what we call it as attribute, but the metric, the word metric and metric, the word attribute, they're not same. Just for us to understand that every protocol has got a metric, we use the word metric. Metric of BGP is attribute, but attribute is more dynamic word. Metric is static. BGP has got rich attribute, very rich attribute, which helps to tune this BGP to achieve policy-based routing over the internet. As the word says, border. This is enabled between every autonomous system. In the borders of autonomous system, we have lot of policies. Within autonomous system, we may not have much policy for the external networks. For the external networks, you will not have much policy inside your organization. For the networks of internet, that is what I call it as external network, you will have policy in the borders because you are talking to the external world. So we need a protocol which has got a lot of attributes to meet our policy requirement. BGP is more friendly than any other protocol. So in the first chapter, we are going to see the concepts, the terminologies that we should know, understand to know BGP. As I said, BGP is used to connect to the internet. See, there is an enterprises down there, 65500, which is talking to customers around the world. There are many customers for these enterprises. Customers in Asia, customers in Africa, customers in Middle East, customers in Europe, customers in West. Customers are all around the world. This enterprises is a big, like, let's say, like Amazon, like Walmart. They have got customers everywhere. So to provide an uninterrupted service, the enterprises have taken two internet connection. One is ISP-A, another one is ISP-B. The reason is maybe you want to do load sharing, the customer traffics are too much, so you want to have load sharing between these two ISPs, two paths to talk to the customer. The second reason may be for high availability, meaning if ISP-A is unreachable, router A cannot reach D for some reason, then all the traffic can go and come via ISP-B. So customer, without any denial of service, they continue getting the service even if one of the ISP that is connected to enterprises fails. Or there may be a policy like all the customer traffic to go via ISP-A, all the enterprises related traffic, business traffic, all the enterprises related, the talking to branch office. So these enterprises may have many branch offices. So to talk to the franchisees, to talk to the branch offices, you may want to use a dedicated path via ISP-B. So, these are the few reasons why an enterprises need more than one ISP. Firstly, I said to load share the traffic because the traffic is too heavy. Second is, if one ISP is unreachable for these enterprises, maybe because of some disaster, there will be connectivity to the internet via ISP-B. So like a backup path. Thirdly, you want to have a dedicated path for all the company related communication and the other path for the customers to use. See, these are all what? These are all policies. To achieve this, you need a protocol that will understand this requirement. BGP can understand this. Now, we call this as multi-homing, connecting to more than one ISP, connecting to two or more ISPs. We call it as multi-home. Multi-home. So in BGP, you will see two terminologies. One is multi-home, the other one is dual home. They are not the same. This is multi-home, connecting to two different ISP. But if you will have an enterprises having more than one connection to the same ISP, this is dual homing. This is not multi-homing because you got two connection from the enterprises to the ISP for redundancy, for load sharing. You're not subscribing to another autonomous system. To the same autonomous system, you have subscribed twice for redundancy, for load sharing, etc. Which is more good Actually, multi-homing is more good. Dual home is good. Multi-homing is more good. How? When we have multi-homing, we got two different ISP. So when you have two different ISP, one ISP may have better route to reach a customer here. One ISP may be having a better route than the other. For the other customer, the other ISP may have a better route. So to reach customer 1, ISP A may be the better path, exit. To to reach ISP 2, customer 2, ISP B may be the better path. So the performance in path selection is better when we have multi-homing. Second is reliability. As we already spoke, if one of the connection to ISP, if connection to the ISP fails, there is still internet connection through another ISP. Yeah. So multi-homing is a very good solution whenever you are having a big business to do with the internet, with the customer in the internet. Just one ISP is not sufficient because you will have the denial of service. Customer will face denial of service. They cannot get service if that one connection goes down, right? So always multi-homing is good. Now, when you have multi-homing, there are three different ways in which we learn route. One, we are learning a default route from both the ISPs, a default route. So using some protocol, it may be by using BGP also you can inject a default route. Now both are injecting default route. So now this router has got exit via B as well as via A, because both are giving you a default route. How will C pick a path? As it is said here, based on the lowest IGP metric. So you will be running some protocol as an IGP, let's say OSPF. OSPF to reach B is cheaper than reaching A, because A has got more hops. C to reach A has got 2 hops. So the cost to reach the gateway, the cost to reach E is cheaper than to reach D. Both are ready to provide you the service. What service? Taking you to the internet. Learning default route is one way. Now, when you learn default route, not the same path the packet is going to take. Maybe C will take this path because this default gateway is low, near less than metric. But D may be going this way. A may be going this way. So somehow a kind of load balance happens. Even though we have a even though we got a default route, What is default route? For all unknown destinations, we route the packet to that gateway. Let us advertise this route. That is default route. So a kind of load sharing, and the routing table of the enterprise's router will have just only one default route to reach the entire world. The whole internet can be reached by just using that one line called a default route. Definitely that saves a lot of buffer in the enterprise's router. The other way is we learn default route. At the same time, we also learn some prefixes, some networks. So ISP advertises, and let's say here in this example, both the ISPs advertises some 10,000 prefixes. So you're learning 10,000 network route information. Router A, B learns 10,000 networks of the internet. But in the internet, we have millions of prefixes. If only 10,000 is learned, all the rest can be reached via the default route. So only 10,000 prefix is not going to take you to the entire world. You still need many network to reach. So we got a default route for rest of the networks. So all well-known customers, all well-known branch office, you may learn prefixes. You will ask the ISP to advertise the prefixes for those well-known. For all the rest, you ask the ISP to provide a default route. That is going to really solve a lot of problem. Problem number one is the number of updates that ISP is going to give you is going to be less, only 10,000 prefix plus a default route. Secondly, the space consumption on A and B, the buffer consumption in both BGP database table and the routing table is going to be less. And the process utilization to process those BGP updates will also be less because it is not a simple protocol. BGP is a heavy protocol which has got a lot of attributes. For every single prefixes, a lot of attributes comes along with that. So if I learn millions of networks with attribute, it is going to be a heavy CPU utilization on those router A and B. So when you learn partial number of prefixes for the remaining, when we use default, we are really saving a lot of CPU utilization and the buffer utilization, the bandwidth utilization, etc. So the device is also going to be fast now because you have saved a lot of CPUs. Next is learning the complete millions of routes. All routes of ISP is given to the enterprises. What is the advantage of this? Advantage of this is you can have a very clear path selection. See, when you have precise route with attribute, then you can make a very accurate path selection. Where some destinations will be easy to reach via ISPA, some destinations may be easy to reach via ISPB. You can compare which one is better to reach the destination and choose the path. So learning the complete routing table from all provider is also another way. But for this, you need to really have a very big router. That A and B needs to be a very big router like an ISP device. ISPs have got devices like ASR, kind of big device, 99, 48, 9004, 9006, 9024, and so on. Big books. So when you have one like that in your enterprises, so then you can easily accommodate that many number of millions of routes in your routing table. So definitely there's going to be more space consumption because the device is too big, the CPU utilization is high, the memory utilized is high, so you will have a lot of fabrics in the device. It's not going to be a normal router, a big router. So we just saw now what is multi-homing and what all the ways in multi-homing the routes are learned. Multi-homing is nothing but connecting to more than one ISP so that you can have more reliability and more increased performance. And now when you have multi-homing, you will have three different options of learning routes. One is learning default route from both ISPs. Secondly, you learn partial route. For the rest, you have default route. Thirdly, you learn full route from ISP. Now, as we said earlier, BGP works between autonomous system. We need to know what is autonomous system first. Autonomous system is group of devices, the network devices, that are governed by one common administration, technical administration. As it is written here, a collection of networks under single technical administration. In an organization, we will have only one administration in an organization. So each organization is one autonomous system. The devices in an organization works for that device, not for the other organization, right? So each organization has got their own administration to administer the network, and this is what we call as autonomous system in general. So when we have many routers inside an autonomous system, to reach those networks of our own organization, we need a protocol. For that, we use IGP. So we need to be very clear in this. What is that? The protocol BGP and protocol IGP are not doing the same job. IGP, when we say IGP, the RAPE protocol, the EIGRP, the OSPF, the ISIS, this all comes under IGP. It is listed even here. These IGP protocols are meant to find the best path for those networks that are inside the organization. OSPF is not going to work for finding the best route to reach this autonomous system. No. That's not OSPF job. OSPF's job is to find the best route for the network from here to here in the same organization. You may have multiple areas in the same organization to find the best path within the autonomous system. Within the autonomous system, we use IGP protocol. The job of BGP is totally different. BGP is also a routing protocol, but this finds the best path to reach for those networks that are away from your autonomous system, reaching the world. See, definitely, BGP is a heavy protocol, a very big protocol. It is talking about those networks that are in the internet, not the networks about the networks that are within your organization. The eyes of BGP is all over the world. The eye of OSPF is within the organization. BGP has got visibility to those networks that are from other autonomous systems, the networks that are in the other autonomous system, other company, other autonomous system. Whereas OSPF, ISIS, EIGRP, RIP has got only visibility to your own networks. I can also say, like in another word, if I need to say, I can say to an extent this is true. IGP works for those private networks which are within the organization. BGP works between those public networks that are coming from the outside. So we will have both BGP as well as OSPF in this autonomous system, but they are not doing the same job. BGP is trying to provide you the path selection to reach the destination, which are outside the autonomous system, whereas the IGP protocol provides the path for those networks that are within the organization. So don't wonder why we run two operating systems, two routing protocol on the same router. Even though we have two routing protocol on same router, the job that they do are not the same. I have a helicopter, I have a bicycle. Are they same? Definitely not, but both are needed for me. I want bicycle to do exercise to go to the nearby shop. I need a helicopter to go and visit my neighbor in the other state. I don't use helicopter to do exercise or to go to a nearest shop. Not possible also. But both are vehicles. Likewise, IGP protocol and BGP are routing protocol, but the job that they do may be routing the packet, but this is locally, that is internationally. IGP is local. Now, every routing protocol, whether it is BGP or IGP, when they designed, they were very, very, very careful to keep a loop prevention mechanism in it within. For example, RIP, if you take the RIP's infinite metric 16 helps to prevent loop. If loop occurs, it won't go more than 16 hop and then it vanishes. That prevents loop. And if you take EIGRP, we have a dual algorithm, diffusing update algorithm to prevent loop. OSPF has got router IDs to prevent loop. ISIS also has got system ID to prevent loop. Likewise, OSPF also have got loop prevention mechanism. One is AS number, autonomous system number, which is used to prevent loop in an EBGP environment. Yes, BGP has got two different uh, I can say two different flavors. This AS number will help to identify if there is a chance of loop and prevents loop in an EBGP scenario. As I said, BGP has got two different flavors. When you run BGP between the autonomous systems, we call it as EBGP. And when you want to distribute the external route inside the organization to the inside routers, we will run BGP even within the autonomous system. We call it as IBGP. In IBGP, there is a IBGP split horizon rule which says route learned from an IBGP should not be advertised to another IBGP. That prevents loop. See, more about these things are coming in detail. I'm just trying to say that the exchange of loop-free routing information is guaranteed by every protocol. OSPF, router ID, EIGRP, dual algorithm, RIP, infinite metric, 16, ISIS, system ID. So every protocol has got loop prevention. They prevent the loop. When they share the routing information, they make sure the loop never happens. BGP comes under a category called path vector routing protocol. Path vector is because it shows the path. Sometimes it shows multiple paths. Say, for example, if you take this autonomous system, to reach these networks, it will show these paths 1, 2, 3, and 4. It will show you 4 paths here. Yes. Among 4, it will pick 1. By using attribute, it will filter one path out of 4 and put in the routing table. So it shows the vector, means the attribute, or in another simple term, the metric, along with the path direction. For example, if you see here in this autonomous system, when we learn these three networks, 24, 25, and 0, 24, 25, and 0, it shows the path which is giving this advertisement, the path through which the autonomous system has learned those networks. These three networks are learned via the autonomous system 520, 600, and 700. This is the path via which the update information have reached. This advertisement will also reach via this way if this autonomous system decides to choose this as the best path. Then this path will be advertised to this and this will be ignored. Again, don't need to think too much here. We'll go into these things in detail later. I'm trying to explain you why it is called path vector protocol. It shows the direction. This is the direction. That's why it is vector. Not only the direction, it shows the autonomous system via which the update has reached, the path. Now, this is a continuation of these 2 points. Here we see IGP operates within an autonomous system. Here it goes in detail. What IGP does within an organization, it announces the networks that are inside the organization, and for each network it also advertises the metric like cost, like bandwidth and delay, like hop count. Yeah? It describes the metric to reach those networks. That's the job of IGP protocol. When we say IGP, it is not IBGP, it is simply IGP, which is OSPF, ISIS, EIGRP, RIP. BGP announces the path and the networks that are reachable at the end of the path. Listen, this announces the networks and the metric, whereas BGP announces the path. You see, this is the path. And at the end of the path, you have these networks. So there's a big difference. It announces the path and the networks that are reachable at the end of the path. BGP describes the path by using the attributes. So when this autonomous system receives this path, and the end of the path it finds 3 networks. It receives this path, and the end of the path it finds the same 3 networks. Now for both the paths, the attributes are going to be different. So this autonomous system will compare the attribute of this path and this path. And pick the one which is suiting the requirement, which suits the requirement. See, attributes can be called as metric, but metric is very small. When you say metric, it's not dynamic. Attributes are much powerful word than metric. You see, human beings have got attribute, but machines have got.
I have a question. Like, BGP is called the path vector routing. That the reason is that.
Yes.
Vector means definitely show the direction.
Correct. Direction.
In which direction the packet will arrive or leave. And the path is basically the reason it works from autonomous system to autonomous system number.
Yeah.
So this is the reason it's called the path.
Correct. Path vector. You see, when you see these autonomous systems, you get the path information, also you get the direction. It is not this direction. When I see 64520, I know it is this direction, and from here it has taken this direction, not this direction. The packet will go via 64600. That's the vector and the path.
Right, yeah.
Right, so basically the autonomous system gives both the path and the vector. The autonomous system numbers that we learn that describes not only the path, it also describes the direction via which the packets are going to follow. BGP allows the administrator to define the policy or the rules for how the data will flow through the autonomous system. You see, we do have attributes, no doubt, but we are not having simply 1 or 2 attributes. We have many attributes, at least 13 attributes. Why do we have that many? So that you can tune to meet the policy expectation, the rules of your company. In what? In path selection. That's the reason why we like this protocol. You can define the policies of how the data will flow through the autonomous systems. It's not one autonomous system, it's internet. Flow through the internet. Internet is collection of autonomous systems. Now this is also explaining you the same thing. We have multiple paths to reach this destinations 192.168.24.25.172.20.00 from here. BGP can support any policy that confirming the hop-by-hop routing paradigm. Now, what does it mean? See, these are all hops. These are all various paths with different hops. So when you tune the policy will be influenced by this AS numbers, nothing but hops. Every AS number is a hop. When you don't configure any attribute, you will see many networks will go via the path which has got less AS jumps. For example, instead of going this way, it will go simply through this way. Because 1, 2, 3 hops. If you go this way, 1, 2, 3, and 4 hops. The hop count is more. But do not compare this to RIP, because RIP, every one hop is one router. Here, we don't know how many routers are here. Here you may have 1,000 routers. Here you may have another 1,000 routers. Here you may have just 2 routers. So going like this, it may look cheaper for you. 1,000 plus 2 router is 1,002 router. But BGP will not see the number of routers. BGP will see only the autonomous system. BGP will see this as one autonomous system, this is another autonomous system, this is another autonomous system. Doesn't matter how many routers are there inside. One hop is one autonomous system. Now this page explains you the reasons for which someone should enable BGP and the reasons for which someone should not enable BGP. 2 things. The reasons why BGP is appropriate, for the reasons why BGP is not appropriate. Number 1, the autonomous system allows the packet to transit through A to reach the other autonomous system. For example, in this diagram, this autonomous system allows the traffic to transit through this autonomous system. Meaning, the beginning is one autonomous system, the end is another autonomous system, but the middle one is utilized. This middle one is neither source nor a destination, but They do contribute in paths.
I have one question in here. So for example, the packet from autonomous system number 64500 is going to autonomous system number 64520 via 65,000 autonomous system number.
Yeah.
So when the packet arrives from 64,500 to 65,000 autonomous system number on that router, does that router will propagate the information to other routers in the 65,000 autonomous system number?
That depends. If you feel it is needed, then you will configure IBGP and make it to propagate. If you feel no, it is not needed, I just have another wire to connect to another autonomous system, and I want only on this router. I do not want any of the inside router to know. Then you no need to enable IBGP. It depends. We'll talk about that.
Okay.
The scenario is coming later.
Okay.
Now, our aim is to understand why BGP is appropriate. Number one, if an autonomous system is a transit, this is a transit autonomous system, neither source nor destination. So they will definitely need BGP because they want to allow the traffic of someone to go to somewhere using their resource. Definitely there will be some policy to enforce the policy as the traffic comes in. To apply the policy, they need BGP here. Secondly, an autonomous system has got multiple connection to other autonomous systems. This is another reason why you need BGP, because I have two autonomous systems to connect. I need to do some sort of policy in path selection. Some traffic should go via the left, some traffic should go via the right autonomous system, which is we called as policies. That is our third point. Routing policies and route selections for traffic engineering, leaving the autonomous systems. We need to manipulate it, so we want BGP. So if you have any of this reason, any one of this reason, definitely you need BGP. If you have multi-homing, you need BGP. If you are a transit autonomous system, you need BGP. If you got some policies in path selection, you need BGP. Now, when BGP is not appropriate, we got very limited understanding of this protocol itself. You don't know how to tune the attributes. You simply know what BGP is and how to enable them, enable the protocol. That is not enough. It's a limited understanding. When we have limited understanding, when we don't have in-depth knowledge of BGP, when we don't know how to use the attributes to tune the path to provide policy in path selection, then BGP is not the appropriate one. If you don't know, then better not to enable it. Simply enabling it is not going to solve problem. You also need to know to tune it. Simply enabling BGP is not going to give you policy-based path selection. Not only that, you don't have more than one autonomous system, just a single internet connection. You tell me why you need BGP. There is no policy needed because you have only one ISP. What policy will have? If you have more than one, you'll say for this I want that. For this traffic I want another ISP. You have some policy. But when you have only one internet connection or only one autonomous system to connect, whether you like or not, that is the only path you have to choose. There is no policy there. Thirdly, the routers that you have are very old routers. They don't have enough power. They don't have enough processor or memory to handle the attributes that comes along with every prefix. Okay, so we have seen here the reasons to go for BGP and not to go for BGP. This page is again another interesting page. As we already know, BGP is a path vector routing protocol, which is not a distance vector protocol. Why? Distance vector protocol is one hop is one router. Here, one hop is one autonomous system. Number two, the distance vector protocol, for example, RIP, it uses UDP, whereas BGP uses TCP. And the port number that is allocated for BGP is 179. So this provides more reliability. In BGP, you have neighbors. In RIP, you never see neighbor. Have you seen BGP a neighbor? Yes. Have you seen RIP neighbor? Never. BGP never discovers neighbor.
Only RIP says the routing update, no neighbor.
Yeah, there is no reliability there. No neighborship, no reliability. And BGP will not send any periodic update. Distance vector protocol RIP will send periodic update every 30 seconds. BGP sends only those changes that occurs and that is sent immediately. To make sure the neighbors are available, every 60 seconds, BGP sends keep alive messages. Keep alive messages are like TCP packets, SYN packet and SYN-ACK. Every 60 seconds it will send to make sure the neighbors are still available. As we already spoke, BGP has got attributes, which is called as rich metric. And as we already discussed, BGP works between the autonomous systems. It's not simply within an autonomous system. So BGP is a protocol which is by default having that design to support the huge internet. Like any other routing protocol, we have routing table to save the best route and follow the path for the packets when they arrive. We have neighbor table. These neighbors are the one which is successfully done with three-way handshake, because BGP is a TCP-based protocol. Neighbors are manually configured because it is BGP, TCP-based protocol. You need to say to whom you need to do three-way handshake. Neighbors are not dynamically discovered. Neighbors are statically configured. BGP also maintains a table called the BGP database or forwarding database, where you will see all possible paths for every single networks. List of all neighbor learn from each neighbor. List of all networks learn from each neighbor. Can contain multiple paths for destinations, and the paths comes along with the attribute. Not simply network is advertised. Along with that, the attribute is also advertised. Neighbor table, BGP table, and the routing table. BGP has got message types, 4 message types. Open message, soon after three-way handshake. I repeat, soon after three-way handshake between two neighbors, a packet called open message is sent with a hold time which is 180 seconds, and the router ID. The router IDs are dynamically picked by BGP. If you have a loopback interface, it is going to take the IP address of the loopback interface. If not, it is going to take the biggest IP address from the physical interface. Same what you have learned in OSPF. As I said earlier, BGP sends the SYN packet every 60 seconds. We call it keep alive. And initially, it will also send the update messages to share the prefixes and the attributes with the path information for every destinations. At last, you will see notification once in a while. You will see notification whenever there is an error detected in a path or when there is a change in the or when there is a drop, something like that. A neighbor failed or link failed, something like that. So you will see a notification message saying the neighbor closed or BGP connection closed, something like that. All right. So in this chapter, we have learned some terminologies and concepts of BGP. Terminologies like IGP, BGP, autonomous system, path attribute, AS by AS, hop by hop. What is the attribute? BGP's port number, keep alive 60 seconds, hold time is 180 seconds. Why we should go for BGP, why we should not go for BGP. And what are the different ways in which the routes are learned in the routing table. At last, we also learned multi-homing and dual homing concepts. Any question on this chapter? We have finished one chapter.
No, this I think it's all good. This is the fundamental thing, right?
Yeah. Now, as we saw earlier in the previous chapter, BGP can be enabled even within the autonomous system. You were asking a question, and I answered saying yes, the external networks sometimes we need it inside all the routers. In that case, sometimes all the routers, sometimes few routers, you may need the external routes. In that case, we will be enabling BGP even within our autonomous system on many routers, not only on the edge router. So when you enable on the inside of our autonomous system BGP and form neighbor with our edge router, the relationship between the inside router and the edge router, we call it as IBGP. The inside router will run BGP just to learn those external routes in the routing table, because you want to reach some external network via that internal route. Otherwise, there is no need. If you don't have a reason like going to internet through that internal route, then you don't need. Mostly people will go to the internet via the edge router. Till the edge router, they come with a private IP address and they get natted on the edge router. In that case, you will not be in need of IBGP. But if you are an ISP, then you will have multiple edge devices. This is very important point to know. You will have multiple edge devices because you got thousands of customers. You are an ISP. You will not have all thousands connected to the same edge router. You'll be having many edge routers. So the route learned from outside on one edge router should be given to another edge router of your own organization. You have many routers as an edge. Routes learned in edge 1 should be given to all other edges. and route learned on all other edges should be given to this edge, for which you need IBGP. Even though it is edges, among the edges of your autonomous system, you want to distribute routes. So you need IBGP. IBGP rules are different. EBGP rules are different. Meaning, the way that BGP forms neighbor in IBGP is loose. The way that it forms neighbor in EBGP is strict. In EBGP, the neighborship is very strict. In IBGP, the neighborship is loose. Because it is your own router between which you form IBGP. The routers are free. The routers are not that strict because it's your own routers between which you form neighbor. Whereas EBGP relationship is between two routers that belong to two different autonomous systems. There you cannot be loose. You need to be very strict because it is two different autonomous system routers. So what is that strict and loose? What way EBGP is strict and in what way IBGP is liberal is what we are going to see in this chapter. Secondly, we will also see a rule called IBGP split horizon rule, in which you'll see route learned from one IBGP should not be given to another IBGP. Route learned from one IBGP should not be given to another IBGP. Why? To prevent duplication of updates and loop. How? We'll see. But this rule sometimes comes as a problem in distributing the routes to more than one hop, because the route learned from one IBGP will not be given to another IBGP, which means the second hop IBGP will not receive update, for which we have a solution described in this chapter called full mesh. That is how this chapter is going to end. But full mesh is not the only solution. We have various other solutions that is not in this chapter. Will be coming in the following chapters, like route reflector. And there is one more called confederation, which no one is using now. It's an old method. And the best solution is MPLS tunnels. But because we are not learning MPLS now, we need to provide a solution only through BGP. So only BGP solution is full mesh, route reflector, confederation. Along with the MPLS, you have a better solution for this problem, IBGP split horizon problem, which is called as layer 3 MPLS VPN. As we move to various chapters, we will understand these things that I've spoken in much detail. Now let us get into this chapter. What is BGP peer? Peers are nothing but neighbors. For BGP, who is a neighbor? The one which can form neighborship by doing three-way handshake. The one which is reachable, with which the three-way handshake is possible. Only then the neighborship can be established, after which the update messages are shared among them and they form neighbor. So very first condition is the BGP peers need to be uh, a pair of router between which the TCP connections are possible. The three-way handshake is possible. See, the second paragraph says the two routers that have formed a TCP connection to exchange BGP routing information are called as BGP peers or BGP neighbors. When will these two routers exchange BGP routing information? First, the three-way handshake. Second, the open message and the keep alive message. Then only comes the BGP update. That is where the exchange of BGP routing information with their attributes are done. Now, we have two flavors of BGP. One is external BGP, another one is internal. External BGP, as we already know, the BGP running between two routers that belong to two different autonomous systems. For example, between router C and X, D and Y. They're eBGP neighbors. Here, what is important is the second line. By default, eBGP neighbors need to be directly connected. Directly, underline the word, directly connected. See, this word is very important, the directly. How important it is, you will know when we go to the next chapter. In the next chapter, when we learn that eBGP multi-hop command, you will know how important it is. eBGP multi-hop command. So when we go there, I'll explain you again the directly connected. It may sound like a simple word for you here. There it will make sense for you a lot. Let's go next. IBGP, internal BGP. The BGP peers within an autonomous system forms IBGP neighborship. So if you see here, the router C and A are not directly connected. C and A are connected via B. C and A are connected via B. I'm telling you, even if you don't run BGP on B, A can form neighbor with C, which is not possible in any other routing protocol. OSPF, you cannot form neighbor with A and C without having OSPF in B. Whereas in BGP it is possible because A and C are already reachable via some IGP protocols like OSPF. Using the reachability, the three-way handshake, the BGP open message, the BGP keep alive, and the updates can go and establish neighbor between C and A. That is the point. Second line says the neighbor does not have to be directly connected. As long as A can ping C, if A can ping C, then you can form neighbor between A and C without having BGP in B. Now you may ask, like, why do I need BGP if A is already pinging C? Understand, I told you earlier, the purpose of BGP is not to provide reachability between A and C. It is to bring the external network on C and A. The external networks that you learn from 65100, 65200. To share that 65100 routes to 65200, C have to give to A and A will give to Z. Likewise, when Z advertises to A should give to C in order to give to X. For this, A and C need to be IBGP neighbor. So this is what I was telling you. When you have multiple edge routers, here we have A, D, C, 3 edge routers. In this case, you need to have full mesh, meaning A should be neighbor with D, B, and C. D should be neighbor with A, B, and C. C should be neighbor with D, A, and B. We call this full mesh. We'll understand these things in much better way as we move to a few other slides in the same chapter.
Yep, sure. Yeah.
Now, to understand that full mesh, here is the scenario. Next 3 slides, this slide and the next 2 slides, is what very important. First, in general here, they are trying to explain us there is an option called redistribution which is not recommended. Redistribution is not recommended. See, for example, between F and E you have EBGP. Between B and A you got EBGP. And between B and E you got IBGP. But there is no BGP on the physical path, D and C. See, between B and E, there is no physical path. The dotted line shows that there is a relationship between B and E called IBGP. It simply says that there is a relationship. Between B and E, there is a relationship. That is not a wire, that is not a cable. The actual path to reach between B and E is via D or C. But this router D or C do not have routes to F and A because there is no BGP. Because there is no BGP, D and C has got no routes of F and A. But the route of F is given to A, the networks of A is given to F. How? A gave to B, B gave to E. Because it's a TCP packet, it can throw it via D or C to E. The updates are delivered by B to E, but no updates are delivered to D and C because they don't run BGP. They are not eligible to receive any update. But B can update E without updating D and C because it's a TCP protocol. So E got the update from B and E has advertised to F, and F routing table shows the route to reach A. And A has got the route to reach F. When they try to ping, from A the packet comes to B, and B tries to forward it to D, but D says, I do not know who is F. So the packet gets dropped. The packet gets dropped. That is what you see here in this page. When F tries to ping the network of A, 10.0.0.0, when F tries to ping the network of A, see it's the same picture, slightly color only different.
So the packet drop, the reason is that this is a BGP packet. Is the reason, right?
No. BGP has given routes. D and C has got no authority to drop BGP packet because it is a TCP packet. The router D have to forward it. There is no doubt in it. But the route to reach 10.0.0.0, See, it's a ping packet. You're pinging from F. You learned the route to reach A. What is A? 10.0.0.0. F routing table
Yeah.
has got the route via BGP update. And when you try using the route to reach a 10 network, your ICMP packet or any packet, FTP or whatever, your user packet, the user packet, goes to E, and when it is trying to go to B via C, packet goes to C, and C says in my routing table I don't have route for 10. Why? Why there is no route?
Okay, because this is the different autonomous system. Yeah.
No. Why C do not have route for 10? Because to C and D that update is not delivered because they don't have BGP there. The 10 network, which is coming from another autonomous system, is now seen in B and E, but not on D and C, because D and C is not neighbor with BGP.
Right. Yes.
So in the routing table of C and D, there is no route to reach that network 10. So packet comes to C and C drops it saying destination host unreachable. See, let's read the line there. Router C will drop the packet on the to the network 10. Router C is not running IBGP. Therefore, it has not learned about the route to network 10.0.0.0 from B. So in this example, router B and E is not redistributing BGP into OSPF. Okay, fine. Now let us go back to this story. Same redistributing story. It's a continuation here. You see the same picture. We know the packet will get dropped on C and D. We know the packet will get dropped on C and D. What is the solution?
Yeah, because C and D doesn't know about the network of A.
Yes, A and F. So what is the solution? Redistribution should not be a solution. That is what very important here we learn. Why redistribution is not a solution? See here it says redistributing this BGP route into OSPF and from OSPF back to BGP may look like a solution, but it is not a recommended solution. The reason is when you take the external routes that BGP advertised networks and give it to OSPF, first thing is there's going to be a heavy process utilization because BGP has got a lot of attributes and it's heavy. And when you translate to a small protocol like OSPF, so it needs to fit in to OSPF now. That is going to be a process utilization. Secondly, OSPF do not know about attributes. So all the attributes will be lost when you redistribute from BGP to OSPF. All the attributes gone. You see, we need BGP for those attributes. When some attributes are tied with the update, those update with attribute gets dissolved. It becomes a simple update now. No attribute, nothing. When you give it to OSPF, OSPF discards all those updates and take it as OSPF route with some cost. Then the purpose, the intention, the reason of we having BGP is lost here. Third reason, when you mix the external route to the internal OSPF, and again from OSPF to BGP when you put, your internal routes also get advertised outside because you are taking every route from OSPF and giving to BGP. Should not mix like that, external routes and internal routes. That's not a good idea. We need to keep BGP as a separate protocol to handle only the external network and OSPF for only an internal network. So the best solution is run BGP on all the routers, so that All the external will be carried by BGP. All the internal networks will be taken care by OSPF. Again, it needs to be full mesh, not partial mesh. So what is partial mesh? B forming neighbor with the D and C only. It's partial mesh. What is full mesh? B forming with the D, C, as well as E. Means if every router forms neighbor with all other router, we call this full mesh. So what we need is a full mesh. The reason is, if you only form neighbor between B and D and D and E, B and C and E, the advertisement of A to B will go only up to D and C. It won't go further. It won't go further. Why? The route learned via IBGP or never propagated to other IBGP peer. Whatever D learned from B or never propagated to E. So you need to make B itself to deliver a copy to E. That's why you need full mesh. Did you understand?
Yes.
So we need to make a full mesh, meaning every router need to form neighbor with all other routers, which will solve the problem. Now every router has got the root, and when you ping from F to A and A to F, the ping happens. Right, so this is not the whole story. There is one story I'm keeping for tomorrow, for the next class. What is that? Why is this rule in first place? I did not want to take it today. I want to take it in a separate class.
Yeah.
So
just repeat one more time, like for that, the last topic, I think, not the last topic, the last
this one, right?
When the,
I'm explaining. An update is coming from A to B. B gives to D, but B cannot give it to F because, B cannot give it to E because B and E are not neighbor. B gives to C, and D and E are neighbors, no doubt, but D is not ready to give to E because this rule says you should not propagate to another IBGP. What is the relationship between B and D? IBGP. What is the relationship between D and E? IBGP. Route learned from one IBGP or never propagate to another IBGP. So to solve the problem, what we do is we make neighborship between B and E also. So when B gives an update to D and C, it will also give a copy to E. So E no need to now learn from D and C. E has learned directly from B. So they all have the route information now through BGP, and now when you ping, there is no packet drop.
And before the, the previous topic, the packet drop one. When you.
So if the packet drop happens, which means there is no route for A and F. To get the route only, we enable BGP on every router here. Why? Redistribution into OSPF is not a good solution because when you redistribute, all the attributes get lost. Not only that, there is a heavy process utilization. Not only that, the external network get mixed with the internal networks because the router takes care of internal. When you mix like that, again, when you redistribute from internal to external, means OSPF to BGP, all the inside router networks also get advertised. So again, you need to put a lot of filters to do that. Not necessary. To avoid this, simple. Go and enable BGP on all router with full mesh. This chapter is very important, though it is a small chapter. Right, we stop here.